Welcome to the third lesson. And this session will explore the deep learning, which is one of the most powerful techniques in artificial intelligence today. But what exactly is deep learning and why it becomes such as a game changer in AI? Simply, deep learning is a subset of machine learning. It's a subset of machine learning, but it uses the artificial neural networks to solve complex problems, much like how the human brain processes information. But how deep learning mimics the human brain? To understand deep learning, we need first to look at a neural network, just like the neurons in human brain, which are connected and work together to process the information. Artificial neural networks, ANNs, are designed to mimic that process. These networks are made up of several layers of interconnected nodes, which are inspired by the biological neurons. Let's talk next about the artificial neural networks, which ANNs. They consist of three main components, including the input layers, the hidden layers, and the output layers. Each node or a neuron is connected to a neuron in adjacent layer or a closest layers. Data is fed into the input layer, then processed through the hidden layers, and the output layer produces the final prediction or decision. Now let's talk about the node's functionality. Each node in the network takes an input data multiplied by its weight, adds a bias, and then passes it through an activation function. The activation function is crucial, which helps the network to decide whether a node should be activated or not based on data that it receives. A common activation function include rectified linear unit and sigmoid. Let's talk about now about the other different types of neural networks. Now that we have understood the basics of artificial neural networks, let's look into three main types of neural network used in deep learning. Each is specialized for different kinds of data and tasks. The first one, which is the convolutional neural network. These are primarily used for image recognition and computer vision tasks. CNNs are designed to automatically detect features in images such as edges, corners, and textures. By using by using convolutional layers, these layers apply filters in these layers apply filters to input images, extracting the meaningful features that help the network to understand what the image represent. A real-world example of image recognition. Imagine using CNNs to classify images. For example, if we want to teach a model to recognize cats and dogs in photos, CNNs will break the image into smaller batches, detect the edges and textures, and uses those features to classify the image correctly. This is same technology used in systems like Google image search and Facebook photo tagging and even self-driving cars that need to identify the pedestrians and other objects. The next type of neural networks, we talk about the recurrent neural networks, RNNs, which are specifically designed to process sensual data. Unlike CNNs and RNNs, it has a feedback loops that allows information to persist. This makes them perfect for tasks that involve sequence like text, speech, and time series data. What are the real-world example? A real-world example which is a speech recognition and language translation. For example, Google Translate and speech-to-text systems like Siri and Google Assistants rely on RNNs. These models process language one word at a time, taking it into account the context from previous words that predict the next word in a sentence. The feedback loops allow RNNs to remember previous word in a sentence, which is critical for understanding the language. Next, let's talk about the Generative Adversarial Network, GANs, which are designed for generating new data. GANs consist of two neural networks, the generator and the discriminator, that are trained together in a process of competition. The generator creates a new data while the discriminator tries to distinguish between real data and fake data produced by the generator. A real world example here, which is AI generated art and deepfakes. And GANs are behind some amazing and sometimes controversial AI technologies. For example, they are used to generate hyper-realistic images of people who don't actually exist, like in the "this person does not exist" website. GANs are also the technology behind deepfakes, where AI can generate videos that makes it look like someone said something that they never said it actually. GANs have incredible potential in the field of arts and entertainment and simulation, but also they raise an important ethical concerns. Training deep networks, training deep neural networks involve a process called backpropagation. This is how network learns to make better predictions by adjusting its weights. Backpropagation works by calculating the error or loss between the network's output and the true output, then sending that error back through the network, adjusting the weight accordingly to minimize the future errors. To optimize the weight during training, we use technique like gradient descent. This is an iterative process that helps the model to adjust its weight in the right direction by calculating the gradient or slope of the error. By following the gradient, the model makes a small adjustment gradually, converting the optimal solution. What are the real-world examples of training deep networks? In practice, deep learning models are trained on huge datasets like millions of images, text, or videos. For example, Google AI for self-driving cars is trained on millions of driving scenarios where the system learns to predict the best actions based on what it has seen in the past. The model adjusts its weight during the training through backpropagation and gradient descent, improving over time to make more accurate predictions. A recap for this session: we've covered the basics of deep learning, from how neural networks mimic the human brains to different types of networks, neural networks like CNNs, RNNs, and GANs. We also looked at the process of training deep networks, focusing on the backpropagation and optimization techniques like gradient descent. Deep learning is one of the most exciting areas of AI. powering everything from image recognition to self-driving cars to AI-generated art.